In this video, we're going to go over how to graph a quadratic equation. So, to graph a quadratic equation, you need to be able to find these things. You need to be able to find a vertex. You need to be able to find an axis of symmetry. You need to be able to find x-intercepts. You need to be able to find the y-intercept. And you need to find the minimum or maximum value, or know whether or not the quadratic is going to open up or down. These are the things that you need to know. I'm going to go over all these in some examples, and we're going to graph some quadratic equations. First off, we're going to go over how to find the vertex. Now, to find the vertex, you need an x-coordinate and a y-coordinate. There's a little formula that helps you find the x-coordinate of a quadratic equation. Negative b divided by 2 times a. That means this needs to be in standard form. This number in front of x squared is going to be your a. The number in front of the x is your b. And this number that's sitting by itself with no variable is going to be your c. You're going to find these numbers in the equation, plug them into this formula, and it's going to tell you what the x-coordinate is for your vertex. Negative b means I'm going to take the opposite of whatever this is and plug it in here. So the opposite of negative 2 is positive 2. And then I'm going to take 2 and multiply whatever a is. The number that's sitting in front of this x squared is a 1. 2 times 1 is 2. 2 divided by 2 is 1. I have found the x-coordinate of my vertex. Now I need to find the y-coordinate. To find the y-coordinate, I'm going to plug this number into this equation. So, 1 squared, because this is my x, minus 2 times 1 plus 2. Follow my order of operations. 1 squared is 1. Then I'm going to do my multiplying. Negative 2 times 1 is negative 2. 1 minus 2, negative 1, plus 2 is 1. So my vertex for this problem is 1. That's my x-coordinate, and my y-coordinate is 1. That's how you find the vertex. Once you find the vertex, the axis of symmetry, the maximum and minimum, a bunch of these other things are going to be really easy. So the first thing I would probably do is find the vertex, because once you find the vertex, you can use that to help you find some of the others. We're going to find the vertex for this one. Remember, to find the x-coordinate, you're going to use this little formula right here. Negative b divided by 2 times a. Remember, when you have this in standard form, the number in front of the x squared is a. The number in front of the x is b. We have no x, so we have no b for this one. And the number that does not have a variable behind it is your c. So for this one, you have an a and a c. That means, what are you going to plug in for this b? You have nothing to plug in there. That means you're going to plug in a 0. The next thing that's going to happen is you're going to go 2 times 17 halves. Some people are going to say, well, I don't know how to do this. It really doesn't matter, because 0 divided by any number that you get down here is going to be 0. 0 divided by a number, whatever this number is, once I do the multiplying, it's still going to be 0. So my x-coordinate is 0. I need to find the y-coordinate. I find the y-coordinate by taking this and plugging it into this formula. 0 squared is still 0. 0 times this number is 0. 0 minus 2 is negative 2. So my vertex for this, my x-coordinate is 0, and my y-coordinate is negative 2. That's how you find the vertex of a quadratic equation. If you can find the vertex, the axis of symmetry is going to be easy. What may throw students off is the axis of symmetry is actually an equation. It is a vertical line that goes through the vertex, and they represent it by a dotted line. It's going to allow you to find points equal distance on either side from that line. So it's a very important thing to be able to find when graphing a quadratic equation. So to find the axis of symmetry, what I need to do is find the x-coordinate of my vertex. So how do I do that? Negative b divided by 2 times a. This is my a, this is my b, and this is my c. Remember, when you take this number and plug it in here, that's the opposite. That negative b means the opposite of this. 2 divided by 2, and what number is in front of that x squared? 1. 2 times 1 is 2. 2 divided by 2 is 1. The x-coordinate is where that line of symmetry goes through that point. So to write the axis of symmetry, you merely need to go x is equal to 1. That's what the equation of that line is going to be. So when they ask for the axis of symmetry, you're going to write an equation, a simple equation. It's simply going to be x is equal to 1. And that's going to be a dotted line that goes up and down through that quadratic equation that's going to allow you to put points on either side equal distance from it. Like the axis of symmetry, if you can find the vertex for a quadratic equation, you can find the minimum value. So what we're going to do is we're going to find the vertex for this quadratic equation and then look at the y value, and that's going to be our minimum value for that quadratic. Our x-coordinate, how do I find that? I use this formula. Again, the number in front of the x squared is a. The number in front of the x is b. I have no number in front of the x. This is going to be my c. So when I start to plug this in here, my b is going to be 0, 2 times 15/4. Again, it doesn't matter what number is down here unless it's 0. If I take 0 and divide it by that number, I'm going to get an x-coordinate of 0. To find the y-coordinate, I need to take this number and plug it into the equation. 0 squared is still 0. 0 times 0 is 0. And 0 times 15/4 is 0. 0 plus 3 is 3. My minimum value is the y part of my vertex. So the minimum value is going to be 3. So if you can find the vertex, you can find the axis of symmetry. Make sure you write it as an equation. And you can find the minimum value. We are now going to take all these components, we're going to put it together, and we're actually going to graph this quadratic equation right here. So again, one of the first things you need to know is whether or not it has a maximum or minimum, whether or not it's going to open up or down. The way you determine that is you look at the number in front of the x squared. If it's positive, it opens up. If it's negative, it opens down. So what number is in front of that x squared? That's a 1. Direction of opening, that would be up. It's going to open up. The next thing they're wanting us to find is the vertex. So remember, to find the x-coordinate, I need to use this formula. This needs to be in standard form. That's my A, that's my B, and that's my C. My A is the number in front of the x squared, the B is the number in front of the x, and the C is the number that does not have a variable with it. So this negative b means the opposite of that, negative 4 divided by 2 times whatever my a is. What number is sitting in front of that x squared? That's a 1. Negative 4 divided by 2 times 1 is 2. Negative 4 divided by 2 is negative 2. I have the x-coordinate for my vertex. I need to find the y-coordinate. To find the y-coordinate, I take this value and plug it into the equation. Negative 2 squared plus 4 times negative 2 plus 3. Following my order of operations, I need to take negative 2 and square it. Negative 2 times negative 2 is 4. Plus 4 times negative 2 plus 3. Now I need to multiply positive 4 and negative 2. It gives me negative 8 plus 3. 4 minus 8 is negative 4. and negative 4 plus 3 is negative 1. That's going to be my y-coordinate. So my x-coordinate is negative 2. My y-coordinate is negative 1. That's a point that I can go ahead and graph on this graph. That means I'm going to go back 2, 1, 2, down 1. And because this opens up, that means my graph is going to be up in this direction right here. And quadratics take a U shape. So I've kind of got an idea of where this is going to be going. I'm going to be graphing points up here. It's definitely not be graphing points down here. Axis of symmetry. My axis of symmetry is my x value written as an equation. X is equal to negative 2. They want you to put a dotted line right through the middle of this parabola. The reason why? I'm going to graph points that are equal distance. Once I find a point over here on this side, it's going to be equal distance from this line on the other side. It cuts this parabola into two equal parts. I'm going to find my x-intercepts. To find x-intercepts, you need to use factoring, the quadratic formula, something like that, to help you find what the x-intercepts are. I'm going to use factoring. Make two sets of parentheses, put x here, x here. I'm looking for two numbers that add up to be 4 and multiply together to give me 3, positive 1 and positive 3. I realize that my x-intercepts, where my x-intercepts are, my y is going to be 0, so this is equal to 0. I'm going to set these two equations equal to 0. X plus 1 is equal to 0, and x plus 3 is equal to 0. When I solve these two, I'll get my two x-intercepts. Subtract 1, subtract 1. X is equal to negative 1. One of my x-intercepts is negative 1. Subtract 3, subtract 3. X is equal to negative 3. One of my x-intercepts is also negative 3. 1, 2, 3. See how these 2 points are equal distance from each other on this dotted line? Negative 1 and negative 3. Another good point to find to help us graph this would be the y-intercept. How do I find the y-intercept? I need to figure out where this is going to intersect the y-axis. And what do I know about something that intersects the y-axis? X is equal to 0. So what I can do is I can go y is equal to x squared plus 4x plus 3. I can plug in 0 in these spots. Y is equal to 0 squared plus 4 times 0 plus 3. 0, that's also 0 plus 3. My y-intercept is going to be 3. 1, 2, 3. I can generate another point over here on this side by using this axis of symmetry. This point right here is 2 spaces away on this side. That means there's going to be another point 2 spaces away over here on this side. 1, 2. That helps me graph this. Remember, parabolas are shaped like U's. So what I'm going to do is I'm going to make a smooth line like this. And this kind of gives me an idea of what this graph is going to look like. So when you graph these, the direction it's opening up is important. Finding the vertex, axis of symmetry is going to help. X-intercepts are going to help. The y-intercept is also going to help. We're going to graph this quadratic equation right here. One of the first things I need to figure out is which direction it's going to open up, whether it's going to open up or down. The way I determine that is I look at the number in front of the x squared. The number in front of the x squared, if it's positive, it opens up. If it's negative, it opens down. This is negative, so it's going to be opening down. The next thing I need to find is the vertex for this. To find the vertex, I need to find the x-coordinate, and I use this little formula to find the x-coordinate. Remember, the number in front of the x squared is my a, the number in front of the x is my b, and this number out here that doesn't have a variable is my c. So I'm not going to have a c for this one. Negative b, that means the opposite of negative 6. The opposite of negative 6 is positive 6, divided by 2 times negative 1. 6 divided by 2 times negative 1 is negative 2. 6 divided by negative 2 is negative 3. I have the x-coordinate for my vertex. To find the y-coordinate, I need to take this number, plug it into my original equation. Negative 3 squared minus 6 times negative 3. This is negative 3 squared. Negative 3 squared is positive 9 minus 6 times negative 3. Now I do my multiplying. This is a negative 6 is going to be multiplied with this negative 3. What number is on the outside right here that you can't see? There's a 1. This is negative 1 times 9. Negative 9. A negative times a negative is a positive. Negative 9 plus 18. I now have my x-coordinate and my y-coordinate. I can now graph that point. I go back 3, 1, 2, 3, up 9, 1, 2, 3, 4, 5, 6, 7, 8, 9. There is my vertex. And since I know it's opening down, it's going to be graphed in this direction. I need to find the axis of symmetry. The way I find the axis of symmetry, I look at my vertex and create an equation from that x-coordinate. X is equal to negative 3. That creates a dotted line going through the middle of the quadratic equation, or the graph, so that I can graph points equal distance on either side of this. It would be good to know what the x-intercepts are down here. Give me some more points down here. To find the x-intercepts, I can use factoring, quadratic formula, square root method. So let's look at the equation. I'm going to use factoring. What I need to remember is anytime I have an x-intercept, the y is going to be equal to 0. I'm going to use factoring to solve this. When you go to factor something, the very first thing you need to look for is the greatest common factor. The greatest common factor of this is negative x. So I'm going to factor out a negative x out of each one of these and get x plus 6. Once I've got it factored, then I need to set each one of these equal to 0. Negative x is equal to 0. That's going to give me one of my x-intercepts, and x plus 6 is equal to 0. Divide both sides by negative 1. X is equal to 0. One of my x-intercepts is 0. I need to find the other x-intercept by solving this one. X is equal to negative 6. There's my other x-intercept. So 0 is one of them, and negative 6. 1, 2, 3, 4, 5, 6. Notice these 2 points are equal distance from that dotted line. Same number of spaces. Since this is already my y-intercept, these are the only points I'm going to use to graph this. And remember, quadratics creates a U-shape. That's what I'm going to create going through those points I have right there.